reaches a critical level, because Hubble needs enough power just to maintain its basic control systems. And if it doesn't have enough power, we'll have to put Hubble into safe mode until we can go up and service it. Because if it actually runs out of power, the whole satellite could start tumbling, and then that's it, game's over. You can't go up and catch a tumbling satellite. So we were worried that we had to get the servicing mission done before 2008, 2009, in case the batteries were going to continue to drain in this fashion. However, we don't have a backup for the batteries on Hubble, but we do have a duplicate set of batteries here on the ground. This was amazing foresight by NASA, because these batteries on the ground were not just the same technology, but they were going through the same charge-discharge cycles as the batteries on Hubble. You know, the 100,000 charge-discharge cycles that the Hubble batteries were going through, well, the engineers were doing the exact same with the batteries on the ground. So you had the same hardware that had been through the same experiences, and so you could then use those as a perfect test bed for trying to figure out how to reverse this decline. So by experimenting with the batteries on the ground, in 2006 they were able to institute new procedures for the batteries, and you can see that the ability to maintain a charge in the batteries actually started to increase back up. So the delay to 2008 time frame was not as worrisome as one would have originally expected. This teaches us two things: that having hardware on the ground that you can work with is a really good thing, and delaying the mission to 2008 didn't really hurt us in terms of worrying about the basic systems of Hubble. Now, this brings us up to the current time. This is the shot from September 20th, 2008, and the shuttle is on the launch pad. And actually, one thing I didn't show you last time is that there was a second shuttle on the launch pad. One of the reasons we had to push the Hubble mission back, it took a while to get the Hubble mission back into the shuttle schedule, is that they wanted to have a backup. If a shuttle goes up to the International Space Station, well, if there's a problem with the shuttle, the astronauts can stay at the space station until we can send up another shuttle to make sure everything's okay. Hubble is an entirely different orbit from the space station, so you don't have that safe harbor. And so the safety precaution in the case of the mission to Hubble was to have a second shuttle on the launch pad waiting. So here it is, the end of September, 2 weeks before launch. We got two shuttles on the launch pad, and then what happens? Well, in NASA speak, we had an anomaly. All right? And the anomaly happened with this piece of equipment, the Science Instrument Control and Data Handler, which is quite a mouthful. So I'm just going to call it the data handler. This piece of hardware on Hubble suffered an anomaly. Now, I can't tell you exactly what went wrong, because the data about what happened in that anomaly, well, this is the data handler. Well, the data was on here, so we couldn't immediately figure out what was going on with it. But this does actually have a backup. The electronics in it has a side A and a side B. So if we had to guess what happened in the anomaly, you'd say, all right, it was a short in the electronics. All right? And so you could move from side A to side B. Let me show you that a little bit in a block diagram. Okay? Hubble has a main computer, which, by the way, is actually just a 486. And that's not really the computer that it launched with. The 486 computer was swapped in one of the servicing missions. So you may think your computer's slow. Well, Hubble, the state-of-the-art for Hubble is still a 486 computer. All right, and that main computer talks to the instruments that we talked about earlier, all of those instruments in the back of the telescope, and it talks to the SIC and DH, or the data handler, as I'm calling it. And what happens is the data that is taken by these instruments goes through the data handler, which then does all the formatting and gets the data ready to send to the ground. Well, the anomaly on the data handler knocked out the side A of its electronics. And this has happened on other instruments on Hubble. The side A goes out, and so we switch over to side B. But this happened 2 weeks before the servicing mission was to go. And we could, of course, activate side B, and of course that's exactly what we will do. But when you've only got 2 weeks to do that, you got to say, can you really go with a shuttle mission and not be sure that this whole system is going to work? Because the side A of the electronics had been working for 18 years straight. We'd never even touched side B. Side B hadn't been used. And so when you have that short of a time, the decision was relatively quickly made that, all right, we're going to delay the servicing mission. That's the first part of the delay. Okay? And so then we tried to reactivate side B. All right? And we had the main computer had to go over to the instruments, pull them out of their safe mode and say, okay, do you have a working interface to side B through to the data handler? Then it put those guys back into safe mode, came over here, tried to turn on the data handler and say, okay, talk to it. Our first attempt at reactivating Hubble, basically rebooting Hubble's science observing systems, encountered two problems. One turned out to be a software problem where we just uploaded the wrong command. And the other one, well, I guess I'd characterize it as a timing problem. From what I understand, a power supply was expected to reach its maximum voltage in a certain amount of time, but didn't get there in time. And we moved on to other things before the power supply was at full voltage. And so by changing the timing of it, we should have been able to bring it up. But having these problems while trying to activate side B reinforced the idea that now this data handler, having only one channel open, was a single point of failure for Hubble. And so while NASA had been leaning this way the whole time, the decision was officially made that we really wanted to replace the data handler in our next servicing mission. So the next servicing mission has been delayed till April or May, late spring of 2009, so that we have time to take the data handler that's on the ground. Again, we have flight spares, we have identical hardware on the ground. We're going to take the 18-year-old hardware on the ground, we're going to qualify it for space, and we're going to fly it on the next servicing mission and replace the data handler. The really good thing about that is actually that the data handler was meant to be replaced. It's only got 4 bolts that need to be taken off, pull the data handler off, put the new one on, and the astronauts describe it as a really easy thing. And compared to some of the other things we'll be attempting in Servicing Mission 4, it really is much simpler. So, having learned the lessons from the first try, we then did a second try at activating the science instruments, and the second try was successful. The instruments are now operational, and they're working through the side B electronics of the data handler, and we're getting data back from Hubble. The proof is not, of course, in the electronics. The proof for Hubble is, of course, in the pictures. And here is the first image to come down from Hubble after reactivating after our anomalies of the last month. And we call this picture a perfect 10. And what you're supposed to see is this galaxy here on the left forms the 1, and the galaxy on the right here forms the 0, and we've got this 10 in space, and it's also supposed to indicate that Hubble is back to being a perfect 10 and producing science again. I know, it's a little bit corny. But what really is going on here in terms of the science is that what you've got here are 2 interacting galaxies. Together, these galaxies are called ARP 147. They are the 147th galaxy pair in ARP's catalog of interacting galaxies. Actually, he called them peculiar galaxies. And these 2 look really kind of peculiar. This one over here on the left, you can see it's got this really sort of thin ring and then this sort of bulgy thing, and they've got that bright blue stuff around it that looks like it's star formation. And the center part of it and the external part of it don't appear to be connected. And that really is kind of funky. And then over here you've got this ring galaxy. But when you look at it closely, we sort of question, is it really a ring galaxy? I mean, the only way you'd get some sort of ring like this is if you had a collision and you sort of like a pebble going into the water creates a ripple, a circular ripple. Well, you could create a circular ripple of all this star formation. We see this in a galaxy called the Cartwheel Galaxy. But we looked at it really closely and said, you know what? Maybe it's not a ring. Maybe, in fact, it's a corkscrew. Because you've got to trace it. You follow it from here around to here, right? This is sort of the core of the galaxy. You can see the colors here are slightly different. And then you've got all this star formation going along here, and it comes back here, and this might actually pass behind this region and then finish off with this tail over here. So instead of being a circle, what you might have is a corkscrew like this, where it corkscrews around, and then you're looking down the pipe of the corkscrew, and it ends up looking like a ring. We do know that these 2 galaxies are relatively close in space, and you see sort of this stuff pulling off over here, and it looks like they're having an interaction. But I gotta say, this is a really peculiar pair. It's really interesting to see the interactions. But what it really signals is that Hubble is back together and it is doing science. Stay tuned.